Going to discuss in this session the topic of Fourier transform. So we are going to see what are the learning outcomes of this session. You should be able to understand the concept of Fourier transform and you should be able to solve problems using the Fourier transform. Now we are going to see what is a Fourier transform, what is its equations. So this Fourier transform is useful for the non-periodic signals, and we can write the Fourier transform using the equation x of omega is the integral x of t into e power minus j omega t dt. This is the Fourier transform using the angular frequency omega, capital X of omega. The same thing we can also write as capital X of f. This is the Fourier transform using the frequency variable f, which will be the integral x of t e power minus j 2 pi f t dt. And the inverse Fourier transform we can write using the following equation as x of t will be 1 by 2 pi integral capital X of omega multiplied by e power j omega t d omega. The same thing we can also write using the integral of capital X of f into e power j 2 pi f t df. Now both of these integrals are same. So we have two equations for the Fourier transform, either using the variable omega or using the variable f. So the Fourier transform can be either capital X of f or capital X of omega. The inverse Fourier transform also we can do the integration of either capital X of omega or the integral of capital X of f. Now we are going to see some basic properties of the Fourier transform. The linearity property tells that if we take a linear combination signal ax1t plus bx2t, the Fourier transform will be also a linear combination ax1f plus bx2f. Now the time reversal property states that if we take the Fourier transform of time reverse signal x of minus t, the Fourier transform will be capital X of minus f. So we have to put in place of f minus f. Now the duality property is important in solving several problems. So it tells that if the Fourier transform of small x of t is capital X of f, then if we are giving capital X of t as the time domain signal and take its Fourier transform, the Fourier transform will be small x of minus f. So you are giving this capital X of f as the input to the Fourier transform. In place of f, you are writing t. For that capital X of t, the Fourier transform will be this small x where t is replaced by minus f. Now another property is the time shifting property x of t minus t naught. The Fourier transform will be e power minus j 2 pi f t naught into capital X of f. The frequency shifting property is the reciprocal of the time shifting property. Now we take x of t, multiply with e power j 2 pi f naught t. Then the Fourier transform will be capital X of f minus f naught. Next we are seeing time scaling property. The Fourier transform of x of at will be 1 by a capital X of f by a. So if you are having x of at, we have to divide by a and even the frequency also. So it will be 1 by a capital X of f by a. Now this is the next the differentiation property. If you take the derivative of x of t, its Fourier transform will be j 2 pi f into capital X of f. Now we are going to discuss the integration property. The integration property tells that the integral of x of tau d tau from minus infinity to t, this is the integral of x of t. The Fourier transform of that integral is capital X of f divided by j 2 pi f plus delta f into x of 0 divided by 2. Now this integration formula we will use in future to calculate the Fourier transform of u of t and also some other signals. Next, we are going to discuss the convolution property. If we take the Fourier transform of the convolution of x1 of t convolved with x2 of t, the Fourier transform will be x1 of f multiplied by x2 of f. So it will be multiplication of the individual Fourier transforms. Now finally we are going to see the modulation property. The modulation property tells that the Fourier transform of the multiplication x1t multiplied with x2t will be the convolution of capital X1 of f with capital X2 of f. So if you are doing the multiplication of the signal and then you take Fourier transform, the Fourier transform will be having the convolution of individual Fourier transforms. Now we are going to solve an example problem. Compute the Fourier transform of the signal x of t is equal to delta of t, which is the impulse signal. So we are going to write the Fourier transform equation. Capital X of f will be the integral delta t e power minus j 2 pi f t dt. Then we are going to simply rearrange the terms and write this integral as the integral e power minus j 2 pi f t into delta of t dt. We simply interchanged the positions. Now that impulse signal, whichever is delta of t, is having a property called shifting property, which tells that the integral of x of t into delta of t minus capital T naught dt will be x of t naught. Now if you compare this equation, the shifting property equation, with the problem, we can see in the place of x of t, you are having e power minus j 2 pi f t. So x of t will be e power minus j 2 pi f t in our problem. Now here delta is having delta t minus t naught. You compare this with delta t. So the t naught will be 0. So the answer of the integral is x of t naught. So you have to substitute in this function this t value as t naught. So you will get e power minus j 2 pi f. In the place of t we have to put 0. So you will get e power 0, which is 1. Therefore the Fourier transform of delta of t is simply 1. This is a very important result. Now next is we have to find the Fourier transform of the signal, the constant signal x of t is equal to 1. Now we already know the Fourier transform of delta of t is 1. Therefore we can write delta of t Fourier transform is 1. Then we use the duality property that if x of t Fourier transform is capital X of f, then if we give this capital X of t, then the Fourier transform has to be this small x of minus f. Then we can observe that comparing these two equations, x of t will be delta t in our problem and capital X of f will be 1. And if we take this capital X of f and write in time domain, it will be capital X of t, which will again be 1. Then the Fourier transform of this capital X of t, which is the Fourier transform of 1, will be x of minus f, and x in our problem is delta, so we will get delta of minus f. The delta of minus f is equal to delta f because delta is a even signal. Therefore the Fourier transform of the signal 1 is delta f. Now we are going to see the Fourier transform of the exponential signal e power j 2 pi f naught t. We have to compute that. So we already know the Fourier transform of 1 is delta f. So we can write for 1 the Fourier transform is delta f. Now we can write this signal e power minus j 2 pi f naught t as e power minus j 2 pi f naught t into 1. Then we can use the frequency shifting property e power j 2 pi f naught t into x of t. The Fourier transform of that will be capital X f minus f naught. So now in this example, if you compare this with this frequency shifting property, this is the problem. The problem is simply e power minus j 2 pi f naught t, that we have written as e power minus j 2 pi f naught t into 1. So now this x of t becomes 1. So capital X of f from the previous problem is delta f, and hence we can write e power minus j 2 pi f naught t into 1, which will be e power minus j 2 pi f naught t into x of t. As per the frequency shifting property, it has to be capital X f minus f naught. So we will get simply delta of f minus f naught. Therefore, the Fourier transform of e power j 2 pi f naught t will be delta f minus f naught. Now we are going to compute the Fourier transform of the cosine signal cos 2 pi f naught t. This is the problem. Now we can write this cos 2 pi f naught t as e power j 2 pi f naught t plus e power minus j 2 pi f naught t by 2. Then we take the Fourier transform of the cosine signal. We will get the Fourier transform of two e power functions. So we have to take the Fourier transform of e power j 2 pi f naught t, which will be delta f minus f naught from the previous problem, and we have to take the Fourier transform of e power minus j 2 pi f naught t. Now that Fourier transform will be delta f plus f naught. Now we have to add both of them and divide by 2. Therefore, the Fourier transform of the cosine signal cos 2 pi f naught t will be this delta function, delta f minus f naught, and the other delta function, delta f plus f naught by 2. I want to thank the audience for your patient hearing. Thank you very much.